Good day! We're going to do some 3D modeling. So today we have this thing. What is this thing, you ask? It looks like a pretty complicated shape. It's actually the stem for a bicycle. So basically you've got the forks, and you put this on the forks, and you put your handlebars through here, and you use it to steer the bicycle. Now, in absolute terms, it sounds like it would be a pretty simple thing. You've got a shaft here, and you've got a shaft here, but the geometry looks pretty complicated, so we are going to have a crack at recreating this. Before we continue, we'll have a quick assessment. Here we've got a central shaft which connects to the forks, and it's tensioned by 2 bolts via a broken loop. On the handlebar end, we've got a separate section that comes out here, and it too gets fastened via bolts to tighten there. So, we've got our fearsome calipers. We're going to take some measurements and we're going to recreate this model in Autodesk Inventor. If you have a look at the screen, here's the completed model. It looks so mighty on the computer, doesn't it? But yeah, we've got a lot of complicated geometries, and we're going to see how we can recreate this in Inventor. So let's get to it. We'll start off as we always do by creating a new standard millimeter part. So we'll come to File, New, and we'll come to Metric and find standard millimeter.ipt and click Create. Beautiful. Okay, so it might be worth talking about when you do have a complicated shape, how do you begin to describe it? I find that it's very, very useful to see where it interfaces with other things, the functional components. So in the case of this guy, what we've got is a shaft here and a shaft here. Now, pertinent to the overall geometry is probably the relative angles and positions of these 2 shafts. So we might start off by creating a cylinder to represent this shaft here, and then another cylinder, or a barrel shape as it appears here, to represent this one. And then we'll come in with the connecting geometry. So back to Inventor. Let's start off by creating a cylinder representing that first shaft. So we've got our measuring tool, and we'll take an OD measurement, and we see it's 37.85 millimeters out of diameter. So cool. We'll come to circle and create a circle about the center point there, 37.85. Great. All right. So we'll click Finish Sketch. And next what we're going to do is we're going to measure the height of the thing. There we go. So it's 45.5. Looking good. So we'll say extrude, and we'll bring it up 45.5. So you might say, oh, that doesn't look like our model at all. Not yet. So what we've done is we've made a solid cylinder to represent this. We'll cut out the hole and the breakpoint later. We'll add in these ears too. What we want to do next is we want to add in this barrel shape that represents the shaft that will hold the handlebars. So what do we need to do when we're modeling that? We need to assess how far high up it goes and how far across it goes. So I'll take some quick measurements now. And this is going to be pretty rough and ready, but all of these videos are. So we've got, it's about 90 across and about 25 up. So that's easy. Okay, so we are going to capture the 25 up and the 90 across by using a sketch on the vertical plane. So I find it useful first to find the vertical plane and make it visible. So we can find it underneath origin in the model tree. So you can expand it out here. And in this case, for me, it's the XZ plane, the YZ plane. So we'll right click it and hit visibility. The shortcut is V. And we're going to specify using a sketch the 90 across and 25 up. There's a couple of ways of doing this. You could use work planes, but we're going to use a sketch for this one. So start off by drawing a line from the origin, and it's going to be 90 across, and then 25 up. Great. We'll select those both, and good practice will make them construction. Good stuff. Okay, so next, what we want to do is we want to make the barrel shape that this captures. Now, it will be very hard pressed to make that shape on this plane. So what we're going to do is we're going to use that sketch to position a vertical plane, and then we're going to do a cross section of the barrel. Maybe the sketch wasn't the best way to do it, but that's okay. It's an opportunity to look at another way of doing things. So we'll come to finish sketch. And what we're going to do is we are going to make a plane that's parallel to plane through a point. And we'll choose the bottom of the cylinder there and the top point of that sketch there. Now, you might say, oh, we could have just made an offset originally, and you'd be right. But have a look at what we can do if we wanted to. Don't follow along for this part if you already know. If we were to modify this sketch, say make it 15, that would move the plane. That's very, very useful. We get an immediately visual way of seeing how things are positioned. Okay, so what we're going to do is we're going to make the cross section of that barrel shape. So we'll come along and we'll make a sketch on this plane. And we have to take some measurements. So we can see that the barrel shape, we're going to use the radii. We can see that the major radii is about 20. And then about 18 or so represents it. I'll just expand this out a little bit. Just make sure that I've got the right thing. Just take in another measurement. Yep. So 20 and about, 18. Okay, cool. So if we're looking at it from the top, that's it. Let's go ahead and we're going to draw it off to the side, but then we'll align it later. So here we go. We'll make a line that's going to represent the length of the barrel, which we will measure as 41.75. So we'll say here, 41.75. Good stuff. Next, we'll come along and we'll put the major and minor radii of it. So we'll say 18 for the ends. And for the mid shape, for the midpoint, we'll make it 20 millimeters. So these end are going to represent the caps of the barrel. What we're going to do though is we're going to make this middle one a construction line. Good, and I'm just going to double check that we've got the right dimensions for that. Yeah, looking good. We're geniuses. All right, so we'll come to arc and we're going to connect these three lines. 1, 2, 3. Beautiful. And now when we revolve that, we're going to get that nice barrel shape here. Okay, so let's go ahead and do that. But first we've got to put it into position. It's useful to come along here and make a coincident constraint between this midpoint here and the origin of our sketch. Although, mind you, it's not showing, so we will have to project it. We'll click Project Geometry, choose that sketch point, and now we can make our coincident constraint between the midpoint here and that sketch point. Looking good, looking good. Okay, so we'll say Finish Sketch, and now let's go ahead and revolve the thing. And we can revolve it around this axis. Boop. Excellent. And good practice, we'll go ahead and hide the planes as we work on them. We can hide that position sketch as well. So what we have here is the vertical and the horizontal shaft. So in the actual model, that would represent this portion here and this portion here. So we've got their rough positions. What we're going to be doing next is we're going to be creating the geometry that will connect these two and also allow these bolts to come in. So we'll first create a loft that will connect the center of this shaft to the center of that shaft in a gradual transition. Now, we'll take some rough measurements, but we'll have some artistic license when it comes to this thing. So let's get to it. So we'll start off by making a sketch at each of the midpoints. So the midplane of this shaft here is the origin plane, and we can create a sketch there. We'll start off by making a sketch, and you can slice the geometry, as in to say that you can remove all the material before the sketch plane by hitting this button here. Where is it? Or F7 if you're a bit more of an experienced user. Now, I find it's very, very useful to project the geometry of everything that plane cuts. So underneath Project Geometry, we can click and click Project Cut Edges. And it's also useful to make them constructions so that we don't accidentally make geometry from them. Okay, so let's go ahead. We are going to mark the center line of the cylinder. I like to use the diagonal line trick, where you draw a diagonal line, we'll make a construction, and the midpoint of that line is the midpoint of that cross section. So now we can make an ellipse, and here we'll go ahead. I don't know the dimensions. We'll approximate as we go. we'll say that this is 16 millimeters major and 60 millimeters minor, 20 millimeters major. I'm not sure if they're correct. They might be correct. I'm sure it's going to look very good. We'll say finish sketch. And next, what we want to do is we want to make a midplane that bisects the cylinder. Now, I would love to say maybe we can get lucky by saying midplane of torus, but it's choosing the wrong axis. That's okay. We'll go ahead and I'll show you it a different way. If you make sketch 2 visible again, this is the one that we used to position the that original sketch, what we're going to do is make a plane, and we can say parallel to plane through a point. So we'll click parallel to plane through a point, select that origin plane, and select that sketch point that we created earlier. Lovely. And just to revisit it, don't do this if you're following along. You can edit the sketch too, and you can modify the design just by modifying the sketch. See? Magic. I'll just undo those. Lovely. Okay, so next what we're going to do is we're going to make a sketch, and it's going to be a cross-section of the I guess the shaft that will connect this. So again, we don't know the exact dimensions, so we're going to have some artistic license, but I'm sure it'll be fine. We'll click start a 2D sketch here, make a sketch on that plane, and as before, we'll click project cut edges. If we hit F7, we can slice the geometry to that plane. And once again, we'll use our diagonal line to choose the center of that cross-section. So we'll select all these lines, right-click, and say Construction. And now we're going to go and draw another ellipse. And this one, it's a bit more narrow. I will take a rough measurement. Oh yeah, okay, so about 28 mil. So we'll draw a rough ellipse and then add in the dimensions. We'll go ahead and say 28 over 2, so 14. And for the major dimension, we'll say, good question, we'll say 18. Yeah, that'll do. 18 mil. Beautiful. Okay, so we'll click Finish Sketch. Now, why did we do that? We've got 2 sketches that are hiding inside these solid bodies, or just hide the solids so you can see them. What we want to do is we want to make a loft that goes from one to the other. So to do that, we'll come along to the Loft tool, and we'll click this sketch here, and this sketch here. Beautiful. Now, if we want to be all fancy pants, it's possible to come to the Conditions tab, and you can change the conditions so that it's got a little bit more of a curve to it. It just affects how it leaves one shape and then enters the other. So there we go. We've got a very fancy pants curve in there. Beautiful. Okay, so we'll hide the sketch planes that we've used, the work planes that we've used, and the sketch. Lovely. Okay, so what do we have so far? We've got, a shaft, a cylinder representing that shaft, a barrel representing this shaft, and we've got a lofted body here. Next, what we're going to do is we are going to add in these humps here. These humps are going to hold the bolts, which are going to hold this part that separates. We're going to take a slightly different approach when we come to the rear barrel, the rear shaft here. But yeah, we're going to make these, I guess you could say, shafts that hold the bolt holes. So let's get to it. We'll go along and we will begin by making a work plane. So going back to the inventor part, we'll make the vertical plane visible. Excellent. Actually, not that one. We'll make this work plane visible. And what we'll do is we will make another work plane from which the bolts will start. So we'll say offset from plane, choose that work plane, and bring it to the forward. Oh yeah. And we'll say, yeah, let's call it 18 mil. This is ending up being very approximate. That's okay. If you want to hide a work plane, it's very easy. You can just select it and you can hit Alt-V, or alternatively, you can right-click it and hit V, or visibility. Okay, so let's go ahead and we're going to make it. So just to refresh your visuals, what we've got here, the bolts come through, they're centrally aligned. And so we're going to model it at the front, and then we're going to make it so that it extrudes backwards. So we'll start off by coming to 2D sketch, making a sketch on the work plane, and we'll come along here and say project geometry, and we'll grab the upper curves of the barrel. And now we'll take a quick measurement and we'll see, yep, it's about 13.5 millimeters OD. So we'll make those projected lines construction. Good practice. I keep on doing this and I think I go too fast. I'm sorry if I do. But you can select these lines using window, right click, and then go to the right and click construction to make them construction. It just means that they won't be considered when drawing closed profiles for extrusions. Okay, so let's go ahead and we'll make two circles, one at the top and bottom, centrally aligned. And we'll say that this is 13.5 millimeters in diameter. And the same, I'm going to use an equals constraint because I don't want to write 13.5 again. Good stuff. And we'll click Finish Sketch. And it's a little bit like art. When you're reverse engineering something, it's about finding the shapes in the overall structure. It's like, one of those artistic things where it's like everyone can be drawn as a circle and as a carrot or whatever. Secret, I took up 3D modeling because I always wanted to draw, but my hands are dumb and can't do it. But I digress. Let's get back to it. We'll go ahead and we're going to extrude these circles. And we're going to extrude them backwards, and we'll take a measurement. I actually shot this last night, but I think I was a bit tired and the quality was really, really poor. That's why you can see the 45.5. That's actually the length of them. 45.5 mil back. Beautiful. Okay, so we'll go ahead and we'll hide workplane 3. And now we've got the two bolt holes that are going to hold this. Lovely. All right, so what comes next? Let's go to our real-life 3D model, the actual component, if you will. We will come back here and add in that cut at the end. What we want to do is we want to smooth this off. So we can add in the fillets and lofts here to make it nice and smooth. And then we'll come in and we'll make the bolt holes for the bolts. So let's get to that. Back to the model. All right, so how can we make it smooth? Lots and lots of ways that we can do this. I've played with a few. I'm going to use a loft that will connect this to a cross section of this shaft, and it's going to look wild. So the first thing that we'll do is we'll make an offset plane from the origin, and we'll bring it forward 25 mil. Great. And for the sketch, we'll make a sketch on the work plane. And we're going to be lazy, and we're just going to say project cut edges, which will grab the cross section of that shaft. Great. All right, we need to make two more sketches. So one here and one here. That is just a circle representing that cross section. So we'll come along here, and there's a couple of ways that we can do this. The laziest way is to say project geometry, or even better, project the geometry of that, which is guaranteed to be a full circle. And do the same on the bottom. You might ask, why am I doing two separate sketches? Lofts can be a little bit finicky when it comes to the geometry, so I find it one sketch works for each loft. So let's go ahead. We're going to make a loft, and we're going to make it from this top cross section. So there we go, that curve there, to this curve here. And we don't want it straight lines. Straight lines are very, very old school. We're going to go curves. So we'll come to conditions, and it's possible to add in some tangentiality. Tangentialness? Tangentiation. If you know, put it in the comments. We're going to make these tangential by putting a directional condition in the... So if you see, do you see how that line comes from that sketch? By default, it's just going straight from one point to another, but if you add this in, it will make it nice and tangential. And you can do the same for the bottom here. You can say it's straight or it's nice and tangential. Lovely. It looks like a manifold for a car. All right. We want to reuse the sketch that we used here because Inventor makes them invisible after you use them. So we'll find the sketch. We will right-click Sketch 7 and make it visible by hitting V. All right. So let's repeat that process. We'll say loft. And we'll grab this cross section here. I mean, the sketch that we drew here. There it is. And choose, come on, this loft here. If we can choose it. Nope, it's not letting us. Let's try again. Come on, you can do it. Curve. Beautiful. And again, we'll go to conditions. And we'll pick the tangential setting. Lovely. Looking very, very mighty already. Great. Okay. So, like I said, there's a little bit of artistry with this. It might not be perfectly like the original, but you get the idea. You can make complicated surfaces by using lofts and sweeps and extrusions and revolutions. So let's go ahead. We're going to add in a fillet using the F key. And we'll choose these surfaces. I might actually start off with a fillet that connects this barrel to the shaft. And another one back here. Lovely. And hit the plus. And now I'll add in a fillet. Ooh, we might need one in there. Not too sure how that will work. We'll see. We'll add in a little fillet there. Oh, I think my inventor's having a heart attack. We might have a manifold surface. All right. Yep. Hit plus. It didn't wig out. And now we can add in a fillet in here. Yeah, there we go. And we've got a nice, neat 2mm fillet that goes all around. Looking very nice. Wonderful. Okay. So what's next? We want to add in a couple of things. So we want to add in, actually we might add in the bolt holes at the very end. Yeah. Okay, so what we're going to do next is we are going to cut the hole through which the handlebar is going to go here. It's also going to have the effect of, actually, no, I might leave that to the last because the bolt holes. No, we'll do the bolt holes now. We have decided, it is decided, we're doing the bolt holes. So, we want to grab the center points of this one and this one. There are a couple of ways of doing this. Traditionally, I like to use a sketch because I'm pretty quick with that. This time we're going to use a work point. So we'll say work point, and here we'll say center of loop of edges, and we can grab that circle there and this circle here. Where are we? Come on, point. This circle here. Beautiful. And next we're going to place down a hole into this. So you can place holes on sketch points or on work points or by clicking randomly if you're a madman or one. Or anyone. And we are going to make these holes. So if we take out this bolt, here we go, we can see that we've got a bolt of yay big. We can use our calipers to measure it. And we can see that it's an 8mm bolt. Very good. So we'll come along here and we are going to make a simple hole with a counterbore. I should have pointed this out as well. I'm not sure if you can see it inside the model, but there is a little seat in there for the head of this bolt, so it sits a little bit more flush, called counterbore, and we're going to include that. So here we've got a counterbore, and we take measurements. The diameter of the counterbore is 10mm. The inner diameter of the hole is for an M8. So we should be, about 7.5. So we can come in here, we can say that that is 7.5mm diameter. The counterbore is 10mm wide, and it's 4mm deep. And now we can place it on these 2 points. 1, 2. Where are we? Input geometry. Choose the positions, that one there, and it's not allowing us to choose the second. That's okay, we'll do them one at a time. That's okay. Yeah, cool. So we can say good, and the direction, we can flip the direction by clicking somewhere. Where are we? Come on. There we go. 40mm. Good stuff. And we'll hit the plus and we'll create another hole at the bottom here. And for the direction, we'll say that direction, flip it, say 40mm, and good. Okay, so we've got 2 holes. You can't really see them in there, but that's there. And now what we're going to do is we're going to hide the work points. So right click, visibility, and we are going to cut that hole there and the gap that separates these two. And the reason why we're doing this will become apparent shortly. It has to do with adding in the thread. So we'll say that that's 28.5mm diameter. We'll make it, I sometimes forget to put it back on the screen. I'll just undo that. We're going to go ahead and we're going to make a sketch here. And we will make project the geometry, and we're going to draw a 28.5mm diameter circle there. We'll click finish sketch. Oh, no, undo, don't finish sketch just yet. We're not done yet. We'll go ahead and we are going to also, while we're at it, cut the gap here. So that gap, I don't know exactly how much it's going to be. We'll say that it's a 5mm gap. So we'll make a center point rectangle. There it is. base at the center there. The height doesn't really matter so long as it clears the material, but I like to be pedantic, so we will put in the gap is 5 mil, and we are going to click Project Geometry, and we're going to use the coincident constraint to connect the end of that rectangle to the end of this. You might ask, why do I care about this? You know, doesn't it matter that it just clears the material? It's if you want to make this parametric and you wanted to change some of the dimensions later on, you want everything to make sense with changes in those dimensions. Cool, so we'll click Finish Sketch. We'll extrude the gap and the hole. Beautiful. Excellent all the way through. And now we have the two sections that make up our part. Now, interestingly, so this part here is a clearance hole, 7.5 or so, and then in there is some thread. So what we're going to do is we are going to specify that thread. So we'll come here to thread, and we'll grab this internal shaft here, and we'll choose isometric M8. And we make sure that it's going the full depth, and then we'll hit apply and create new thread and do the bottom as well. Lovely. So there we go. We've got a way to bolt these things together. And now, just for the matter of safety, we're just going to add in some fillets here so that people don't cut themselves if someone were to ever take this misbegotten design and actually manufacture it. So there we go. We'll go ahead and just put in a 1 mil fillet there. So it's nice and smoothish. It's also polite to add in some fillets onto the outside there, and hey, it looks cool as well. Beautiful. Oh, there's also some on the inside. I'll go ahead and add those too. 1, 2, 3, 4. Lovely. Great. Okay, so we've got the front. Let's go ahead. Oh, yeah, I won't bother with fillets for that one. Let's go ahead and do the rear shaft. So let's go ahead and review our model again. We can see that it's a broken ring with a gap there. And the gap looks to be, rather than just a separation, it looks to be on an angle. Now, I am going to approximate a 4-degree angle using my eagle eyes. So we are going to cut this central hole and a 4-degree wedge in there. This might not be the right way of doing it. I didn't properly reverse engineer this thing, but if you know how it's done, do let me know. 28.6 for the shaft and a 4-degree fan gap. So go ahead, we'll make... I'll show you my screen first. Excellent. So we'll go ahead and make a sketch on the top of this barrel shaft, and we will make it 28.6 millimeters. Good stuff. And also we'll go ahead and we're going to add in a line there, a horizontal line here, and a third line like so. I should have connected those, so I'll use a coincident constraint to connect the end of that line there to there. So why 3 lines? It's a lazy way of making the gap. So I've got a 4 mil span, so each one of these spans is going to be 2 mil. There we go, for a total gap of 4 mil. I'll make the center line construction, and we should be good. Let's go ahead and finish that sketch, and we can extrude that center part, that little wedge in there, and that gap there, and we're going to cut them to the other side. Excellent. So we'll say OK. And now, if you can use your imagination a little bit, we've got that broken ring there. So what's next? What we need to do is make these little ears here that are going to serve as I guess, what do you call them? Little shelves that you can put the bolts through and then tighten them together. I am sure that I'm going to get this wrong, but we can get the principle of the thing by getting started. So let's go ahead, we'll go back to our model. And we are going to make those Mickey Mouse ears. So we'll make a sketch on that surface there, and we can hit F7 to hide the plane. Sorry, and that should be good. Yeah. Okay, so we'll come along here and we'll say start a 2D sketch. Oh, well, we'll start off by clicking project cut edges and making this side construction. And we're not going to do this twice for the second, we're just going to mirror what we do. This shape can be approximated by a bunch of circles, and taking measurements, we can see that each of those circles are about 16 mil in diameter. So I'll draw 3 circles, 1, 2, 3. If you're wondering how to draw a circle in Sketch, Hitting C won't do anything, hitting Shift C won't do anything, hitting Control C won't do anything because that's copy. It's Control Shift C. Save your life. Oh, I know. Okay, so let's go ahead and we're going to make these all equal. We'll say equal 1, 2, 1, 2, and give it a dimension of 16 millimeters. Lovely. We'll make them all tangential so that they're all touching each other. Good. And lastly, make them tangential so that they're touching the edge there. Okay, so we need a way to position these so that they're in the middle. There's also an infinite number of solutions, so we have to tighten this down a little bit. We don't know the exact measurements, so we're going to take some license. We're going to use a horizontal constraint to make sure that this, the center point of this circle here, is horizontally in line with that point there. Excellent. Okay, next what we need to do is we need to fix their position. Now, this can be done in a couple of ways. I am going to be lazy, and I'm going to draw two 12mm circles. So I'll make them equals. Give one the dimension 12mm in diameter, and make them tangential to that circle here and that line there. And repeat there and there. And now we should be able to connect them if we're clever. So here we can say, yep, let's horizontally align that center point there with that corner there. And yay, okay, this bunch of circles, despite appearances, I promise you, will end up looking like these little flanges here. Flange, that was the word, it came to us. Okay, let's go ahead and we'll click Finish Sketch. And we'll take a measurement of the flange thickness. We can see that that's about 9.5. So we'll go ahead and, again, this is probably not the greatest way of doing it, but if you've got a better way, do let me know. We'll hit the Extrude button, grab that cross-section there, and we'll grab each one of these, and it's going to be great. There we go. Good stuff. And that looks, well, it looks approximately right, but it's in the wrong direction. So we flip the direction using that arrow, and put in 9.5 millimeters, and make sure that it's joining, adding material, rather than taking it away. Good stuff, good stuff. Okay, now we're not going to be hasty. We're not going to mirror this to the other side because there's some features that we want to add in first. So say, for example, a fillet here. That would be nice. Let's go ahead and add in a fillet. It's going to be big. We'll say that it's 3.5 millimeters. No, 4 millimeters. We're going to town on this fillet. And we might also add in some more fillets on the top and bottom. So we might say top and bottom there. Let's go ahead and add in a 2mm fillet will do. Lovely, looking good. There might also be other fillets, but we'll add those in after. So what we want to do next is we want to put the holes that go through here. Now, if I take out this bolt, I can see that it's not only the same bolt as before, but it's also got the same internals. So we've got a counter bore in here and threading on the other side. So let's go ahead. What we're going to do is we are just going to model just the internal hole, not the counter bore, for reasons that will become evident later. Okay, so we'll come along here. We'll say create 2D sketch and make a sketch on that. And we'll use project geometry to grab these circles here. And that will give us the center point. We'll make one circle there, another circle here. Use the equals constraint to make them equal to one another. And we'll put in 7.5 millimeters because that's their diameter. Great. And we'll say extrude. Now, we're not including the counterboard just yet. I promise you there's a reason, but we'll share that as it goes. Okay, so we've got that flange looking pretty good. Now we're going to use the mirror command. So we'll make the bisecting plane visible. And now we'll use the mirror command. So here we go, mirror. It's under the pattern. And we'll grab the features that make up that flange. So here we go. We've got extrusion 5, fillet 6, fillet 7, and extrusion 6. Beautiful. I find it's very useful to select them from the model tree rather than from the graphical window because you can get a lot of craziness. Okay, so we're choosing features. The mirror plane is this plane here. And we click OK. Wonderful. It's looking good. It's looking good. We'll make that invisible. And now, okay, why do we leave out the counterbore? It's because now what we're going to do is we are going to model in the counterbore because it only exists on this side. You might notice that the holes don't line up, and that's true. That's why I said this might not be the best way of making such a flange. But if any of you have ideas on how to do it properly, I'm all ears. Alright, so we'll put a 10mm counterbore in there, 4mm deep. We could have done this with a hole tool, but this is just another way of doing it. And on the other side, we'll go ahead and add in our thread. And we'll put in a thread here, and it's an M8 isometric. And do the same for the bottom. Lovely, excellent, good. Okay, so we'll go ahead and we'll just add in some friendly fillets here, so that no one gets hurt. Lovely, good, and good. Oh! That's looking fantastic. I think that's just about done. Okay, so what's there left to do? We need to put in a material, and we can use that to approximate the weight. And so we'll do that first. To change the material, we'll come along to here, generic, and we're going to assign aluminium 6061, because I'll assume that that's how it's been cast. And we'll change the appearance from aluminium flats to aluminium cast. No, actually, let's give it a cool paint job like in real life. So we'll come along, we'll find some cool paint, we'll say glossy black. Oh, that looks fantastic. In fact, it kind of looks like the model we started with. That never happens, so yeah, excellent. All right, so now you might be saying, hey, Frankie, we screwed up. We've got this part, but what we want is an assembly. Technically, it's an assembly. You know, we've got this component here and this component here, and you'd be right. So the first thing that we're going to do is we're going to save it. So we'll hit Control-S or File, Save. And we'll go ahead and we will put it in our file. So we'll say, we're going to call it Bicycle Stem Multi-Solid Body, so MSB. Now, the idea of this is that we are going to have an assembly that's derived from this part, and those and we're going to separate the geometries into separate solid bodies, which are going to become their own parts. I know that sounds like a garble of words, but behold the magic. So we'll say save. And now what we're going to do is we are going to make this plane here visible, just for the moment. Okay, so at the moment we've got one solid body. We want to separate it into two solid bodies. So to do that, we just need to come to Split. Make sure that the split is set as a solid, because this is at the moment splitting faces. We'll say solid selection. And now for the tool, we will select that plane. And if we say keep side behavior, we'll keep both sides. We click OK. Now we can make that plane invisible. And now we've got two solid bodies. Yay, fantastic. So we'll say, I don't know what to call these. Well, I'll call this one, we'll say bicycle stem main body. And we'll call this one bicycle stem handle cap. I panicked. I don't know. Maybe handle cap. Lovely. So two solid bodies. Okay. So again, we'll save that. And now the magic. How do we turn this into an assembly with parts? So we'll come along to the Manage tab. And we'll click Manage and it'll load eventually. And here we can say Make Components. You can click Make Parts and select the parts individually, but Make Components will make the assembly as well. So we'll say Make Components, grab the two solid bodies, and now we can choose a template for our assembly. So we'll say Metric, Standard Millimeter, and for the location, I will put it in the folder for this video. Lovely, good. And it says bicycle stem. I'll get rid of the multi-solid body because it's no longer what it is. And click Next. Repeat the process, choosing a standard for each of the parts. So we'll say Metric, Standard Millimeter. Click OK. And now, ta-da! We've got an assembly with two separate parts in it that are each of the components. So I'll save that. And very quickly, we'll just go into the parts to make sure that I didn't hide the rabbit in my hat before it materialized. There's the part by itself. Wonderful! Oh, okay. I hope that you learned something from it. I hope that you enjoyed it. If you have any ideas about what you want my next video to go on, please leave a comment or message me directly. I'd love to know what your thoughts are. Continue modeling. Have a great time. Thanks for your attention and see you next time. Bye.